Discussion was about CBR. It's case-based reasoning. So for those who were absent last time, case-based reasoning is a technique actually that tries to solve problems, existing problems, the new problem based on the solutions we have applied from existing problems. So it means that we're trying to match the new problem to the databases of similar problems we had in the past. So normally, we call problems as cases. So whenever you see the word problem or cases, we just mean the same thing. So whenever we have a new problem, we try to compare this new problem with our existing problems that we stored in the database in the past. Normally, these problems that we have, we call them the previous cases, they were already solved, meaning we had solutions for those problems. Now, what we're trying to do using CBR is that we try to look at if this new problem that we have here has similarities with the older problems we had in the past, and we try to compare it, the similarity. The logic is very simple. If the new problem is same or somewhat equal to the old problem that we had from the database, and then we're just going to apply the solution that we applied from the old problem to the new one. Because in CBR, we have this assumption that similar problems will have similar solutions. So what we're going to do is we have to retrieve those problems having similarity with our new problem, and we adapt the solution, or we use the solution and use it with our new problem. So this is how we go with the CBR. And CBR, as I've discussed last time, it has cycles, and I think it's part of your assignment. So the first cycle of the CBR is retrieve, meaning we find similar problems. Okay? And please remember, most of the calculations, most of the math calculations of CBR are in the retrieve process. Okay? We're going to compute for the similarity. So on the retrieve process, our target is to look for the similarity, okay, of the new problem with the old problems. We're trying to look for the, for the spelling, for the similarity. Okay, that's our main goal, to look for the similarity. So later on in the discussion, you will see how we compute for this similarity. Okay, because we need to look for the similarities I mentioned earlier so that we could adapt the solution. Now, if we found similar problems, and then we proceed to the next step, which is number 2. Okay, so what you will do is reuse the solution. Okay, if similarity is found, and then we have to reuse. If there is no similarity, meaning the problem is unique, the new problem is unique, meaning there is no match with the existing database. So what we will do now is we're going to skip reuse, because we can't reuse the solution because it's not similar with our new problem. So what we will do now is we will move to the next one, which is revise. Okay? Revise means we're going to repair the solution. Okay, let's say for example, after checking the similarity, we have found that the existing problem is only 30% similar with the new problem. So it means that we cannot reuse the solution, right? Because the difference is very huge. So basically, if the similarity is about 95% perhaps, or maybe 100%, depending on your threshold, if the similarity is 95% or 100, meaning the old problem is almost the same as the new problem, and then we can reuse the solution. If the old problem and the new problem has very less similarity, then we have to revise the solution. We have to create our own solution. Okay? We have to create our own solution for that new problem. So what happens now is this solution and the problem, we have to retain it in our database. Okay? We have to record it. So what you will see, as time goes by, our CBR system is having too much records of past problems and their solutions. So you will see. So what happens now is, as our database contains a lot of past problems and solutions, it becomes more intelligent. So that's what makes CBR learn from experience. I think last time we stopped with the calculation. For the sake of those who are absent last time, we actually went through this. So this was the problem we tried to solve last time. This is about the dam. Okay, this is about the dam. So the dam has a gate. Okay, and the role of that gate is to control the flow of water from the dam. Do you know what's a dam? Do you know what's a dam, ladies? So let me just try to see if we can look for a picture of a dam here. Bing. Or is that one? I think we could look for not this one. I think we can look for dam. As far as I remember, we can't do it in here. Not here, I guess. I'm just go with Google. That's better. So I'm just type for dam. So this is an example of a dam. Okay, this. So I think we have plenty of dams here in Oman. So this is an example of a dam. For those who haven't seen what a dam is, this is an example of a dam. Let me look at this, okay? Okay. Do you see my screen now? Do you see my screen? Friends, can you see my screen? So this is an example of a dam, okay? So normally, a dam is connected to several rivers, okay? So this is a dam. So for those who were absent last time, a dam looks like this. And a dam is used to control the flow of water. You will see there are gates here. Okay, there are gates. So the water here from the dam, if you will see, is coming from different rivers, different wadi. We call them wadi in Arabic. So these rivers, they have water in it, and water flows into one single location. We call it a dam. Okay? So dams are used by countries to generate electricity. Okay, so they are used to generate electricity. So in these gates of the dams, there are some turbines that are used to generate electricity. So the force of the water coming from the dam, the pressure, generates this turning force for the turbines. So the turbines will turn and then generate electricity. But the common problem with dams is that if the gates were not properly opened or closed, what will happen is it might overflow. You will see here, right? It might overflow or it might break if too much water is in it. So if too much water is inside the dam, it might break or it might overflow. So if it will overflow, it might endanger the cities and residents excuse me, nearby the dam. So it might flood. It might flood the nearby cities and damage the nearby cities. So proper decision making must be done on the timing when to open the gates for the dam. Okay? So this is our problem. Okay, this is our problem. So we want to determine whether to open or to close the gate of the dam. You have to remember, I told you earlier, if we will not be able to make decision either to open or close the dam might break or water from the dam might overflow. Is the problem clear? The case study, is it clear for you? People? Is the case study clear to you? Is it clear?
Yes.
Okay, good. Now, based on the case study given to us by Malaysia, we have 5 rivers connected to our dam. The name of the first river is Pahang, the next river is Soy, the next river is Pekan, the next river is Gambang. So all in all, we have 1, 2, 3, 4. So these attributes here, we call them attributes. These attributes here will dictate whether to open or close the gate. So as per the record from the past database, according to our records here, on day one, the dam water level was 29.26 meters. Then River Pahang has 11.06 meters. Soy has 30.40, so on and so forth. So the decision was to open the gate. And then on day 2, the level of water from the dam and from the rivers changed. The level of water changed for the dam, for the 4 rivers. So the decision was to close the gate because not enough water to generate electricity. And then the 3rd day, same decision was made to close the gate of the dam. On the 4th day, the water level changed, and then they decided to open the gate. Okay? They want you to open the gate. Now, on day 5, our problem now is on day 5. On day 5, there is a change in the water levels for the dam, for the river, for Soy, for Pekan, for Gambang. You have to know, my friends, Malaysia is a tropical country, meaning rain is always in there. It's always raining. Fi matar, as you call it in Arabic. It's always raining in Malaysia. That's why you will see the level of the water in the dam and the level of waters in the rivers are changing every day. From day 1 to day 5, the water level changes. So therefore, the gate also, the decision whether to open or close the gate is also changing. So now our problem is on day 5. On day 5, what do we need to do for the gate? Are we going to open or are we going to close? So same principle as we go with CBR. If you remember, CBR will try to propose solution to our new problem by looking at the old problems. So if you will see this one written here are actually old problems, okay? We call them old problems and solution. They are our old problems and solutions. So this one recorded here were our old problems and solutions. This one are old problems and solutions. Okay? So from these old problems and solutions, we're going to retrieve which do you think, or which should be one of the problems here has almost the same similarity with our problem here, which is day 5. Which do you think we're going to use as a solution? Is it open, close, or open? So we're going to do it later on. So we're going to calculate it using CBR to determine which among these 4 old problems will be similar to day 5. You have to remember the rule in CBR is if new problem, okay, is almost the same as the new problem, new problem, old problem, old problem. Then we're going to apply the solution. Okay, this is our rule in CBR. If new problem is similar to the old problem, apply the solution. It means that if day 5 is similar to day 1, and then we're going to apply the solution here, which is open the gate. If day 5 is similar to day 2, and then we're going to apply the solution, which is close. So on and so forth. So our goal now is to look from day 1 to day 4, which is similar to day 5. So we're going to calculate it using CBR. Last time, which is yesterday, we discussed that when we go with the similarity calculation, wrong spelling, sorry, similarity. In the similarity calculation, CBR is using 2. Okay? We compare first the local similarity, okay, and then we compare the global similarity. When we say local similarity, we want to compare the attributes of the new versus the old. Meaning, in this example, we want to compare, is this similar to this? How similar is this to this? How similar is this to this? How similar is this to this? That's why we call it local similarity. How similar is this to this? To this. Then same thing for Pahang here. How similar is this to Pahang here? How similar is this to this? So on and so forth. So it means that in the local similarity, we're only trying to compare each dam versus dam, Pahang versus Pahang, soy versus soy. All of the values here, we have to compare with our values here, with the new problem. Okay, so this is our new problem. Okay, now when we say global similarity, we're trying to compare the build-up of all the attributes, meaning this one as a whole, this one as a whole, this one line here, how similar it is with this as a whole. Okay, so that's what we compute for the global similarity, the build-up of all the attributes, meaning dam water level, Pahang, soy, pecan, gambang as a whole compared to here, dam, Pahang, soy, pecan, gambang as a whole. So these are the two similarity calculations. Now, after you finish calculating the LS and the GS, you can now decide which problem is similar. Okay, which old problem is similar to the new problem. Okay, so this is our ultimate goal. So after calculating the similarity, we can now decide which old problem is similar to the new problem, and we're going to either use or revise the solution. Excuse me. Now, under local similarity, we have two types of cases, because values can be represented either in number, numerical, or in form of words. Okay, so normally this, when you say numerical, they could be age, height, amount, etc. When we say discrete, they could be gender, like male, female, civil status, married, single. Okay, so these are normally expressed in words. So in this example that we have, all of them are presented in continuous values, right? Because they are expressed in numbers. Okay, so these are examples of numerical or continuous values. So that's why we're going to work for continuous values here. And we discussed yesterday that we have different formula for each type of case. So if you're working with discrete value, the formula is here on top. You just have to follow this. Local similarity of A and B equals 1 if A is equal to B. A نفس الشيء B and then 1. If A is ما نفس الشيء B and then 0. How could I say it in Arabic? لو A B نفس الشيء and then 1. لو A ما نفس الشيء B and then you go with 0. Okay? So this is very simple for discrete. If they are not the same, boy equals boy, 1. Boy equals girl, 0. Male equals male, 1. Female equals female, 1. Female equals male, 0. If they are not the same, they will get 0 automatically. If they are the same, it will take 1. So A here represents the new feature, meaning your new problem. A here means new problem, and B here represents the old problem or the previous. Okay, so in this example in this example, how could I put this at the back? Sorry, so let me just get this one. Okay, so in this example, this is our new, this is our new, this is our old, this is our new, this is our old. Okay, so as simple as like this. You have to remember A means new, B means old. Okay, so you will see there is a range here. For the continuous value, we have the formula 1 minus the absolute value of A minus B. When you say absolute value, we don't care about the sign, okay, if it is negative or positive. So if you will get, let's say, if you will get negative 4, this one, kaliwali, just ignore this, okay, make it 4. So we don't care about the sign for absolute values. Over the range. So how do we calculate the range? Range means max minus min, highest minus lowest. Okay, range is also similar to same as highest minus lowest. Okay, don't forget that, the same. So which range we're going to look for? So the range are actually here. Okay, for each attribute you're going to calculate for the range, highest minus the lowest. That's why you will see here the range we calculated yesterday. We have 29 minus 27, 29 minus 27, you will see this, right? 13 minus 10.11, you will see this value. So this is how you calculate the range, because we require the range for the continuous value here. So I think yesterday I was giving all of you assignment, right, to calculate the similarity for each field. Did you do it? The assignment I told you to do last time? Did anybody do it or nobody did it? I think nobody did it, right? Anybody? Did anybody do it or nobody did it? I think nobody did it. So let me just move it here. Please help me here so that we could finish this calculation. Okay, yesterday we finished calculating this 29.5 minus 29.6, because we had it. Let me just get the sample here, this given problem here. So we have it with us here, this value, or I might open the PDF here. Let me get the PDF. Okay. So this is our new, this is A, okay, 29.5. So you will see all of them will be having 29.5. You will see it. Okay, so we'll get it in here. 29.5 minus, for the first one, 29.6. Then the second one is 29.5 minus 28.99. Can we solve for the next one? Please help me for the next day. So let us just write something here. Local similarity of, I have to write like here, DOM, day 3, okay, DOM, okay. So we're going to calculate, I'm sorry, so I have to write this one like this. Sorry for this notation. So D1 on, comma, D2, D5, right? So you want to check the similarity of D5. This is D5, okay? Don't forget. This one is D5, day 5, okay? So we're going to calculate for the similarity of day 1 and day 5. Day 5 and, which is 29.5, or it should be like this. Not to confuse you, it should be D5, D1. So that to make it very short. So this one also LS of D5 and D1. D2, right? So just calculate it like this. How about the LS of D5, D5 and D3? Meaning we're now going to work with D3 here. This one equals, which one? 1 minus the absolute value of 29.5 minus day 3, which is this one, 29.5. 29.5 divided by, which is the range, which is 2.49. 2.49. Can anybody tell me what's the result for this? Anybody can tell me, please? So let me just open my calculator. Clear. Is it clear? This is 1 minus close parenthesis shift absolute value of 29.5 minus 29.5, then out, divide by 2.49 close parenthesis, you will get 1, right? So the answer here is 1. So the answer here is 1, or simply equal to 100%. Obviously speaking, day 3 is very similar with day 5, right? So we will get 100% here, obviously, meaning they are 100% similar, this. How about the next LS? Are you all listening? Or you're all sleeping? Hello? LS of...
We are listening.
Very good. LS of D5 and D4. Can you tell me please? 1 minus absolute value of 29.5 minus, on top please, 27.1, right? 27.101, sorry, divide by 2.49. So using the calculator, let's calculate it. Let me just go with the values here. 29.5 minus 27.1. How to delete it? Where is the delete key for this? Del 27.1, right? Del 27.01. So the answer should be 0. Well, it's like this: 1 minus close parenthesis shift absolute value of 29.5 minus 27.01, then out close parenthesis, divide by 2.49, we will get 0. 0, right? Is it 0?
Yes, doctor, even me.
It's 0.
Yeah.
Okay, 0. So we will get 0. I hope this is really 0. I'm doubting with my own answer. 1 minus close shift absolute 29.5
Doctor,
minus.
maybe 0 point something coming off.
Yeah, I think so. Very good. 2.49. Yeah, it's 0. So it's double check. So meaning this one, 27.01, is 0% similar with 29.5. So this is how we get it in this calculation. So what's next? We're done with local similarity for the dam, right? LS, sorry. This is LS for the dam. Are we finished? Are we finished? Hello, are we finished? Not yet. This is only for the dam. We're not yet finished with Pahang, Soy, Pecan, Gambang, and Gate. So I'll be giving you the responsibility to calculate Pahang, Soy, Pecan, and Gambang. Who can I assign to do it? Then you will help me. Who wants to do it and help me?
Yes, doctor.
Okay, so please, Ibrahim, do Pahang. Do Pahang. And I want, so Ibrahim will be doing Pahang. And then Riham will be calculating Soy. Okay? Riham will be calculating Soy. Rim will be calculating Pecan. And Najla will be calculating Gambang. Okay? I'll give you around 10 minutes to do it, and then you will calculate later. Okay? Do you need a PDF? Shall I send a PDF to you in the chat board?
Doctor, can you freeze this so we can get the number?
I put the PDF in the chat board. You can download it. The PDF I gave.
Okay, thank you.
No problem, no problem.
Sir,
Yes.
me what I do? Or
You have to calculate pecan, I think. Is that correct, pecan, for Riham? We're going to calculate the local similarity for pecan.
I think Doctor second one, CEO,
Soy, yeah?
sorry, yeah.
So who is for pecan? It's
I'm the first one.
okay, this is pahang is for
Pahang,
you,
I'm Pahang.
and
Yeah.
then soy for Riham, and then pecan for Rim, I think, and gambang for Najla, I think. Ready? Can you give me the values now?
Yes, doctor.
Okay, for Pahang, tell me please. Let me just write here. LS of D5, P, Pahang, 5 for D5, D5 and D1. Tell me please. Values only.
D5, how D5?
D5 and D1, the values only. The difference between Pahang and Pahang. No, sorry, P1. No, D5, yeah, that's for day 5 and day 1. Day 5 and day 1. Tell me the difference for Pahang. LSP, Pahang.
Oh, Mr. I did wrong.
Why?
Yeah, I have to take 12 for, yeah?
You have to take 12 minus 11.6. Yeah.
Okay, I'm wrong, Mr.
Over 2.98.
Doctor, I'm wrong.
No problem.
I took 13.09.
It should be
I'll do
12.
again.
Yeah, no problem. 12 minus 11.6. Okay, 1 minus 12 minus 11.6 over 2.98.
Okay, I'm doing it.
No problem.
Doctor, for the first one, equals to 68.4%.
Give me the decimal value, please.
0.684.
0.68. Just
Oh,
give 0 equals 0.684, right?
yes.
685, actually, round off 685, or this is
68.5%.
Very good. Very good. How about for the next one? LS Pahang for D5 and D2.
Doctor, question.
Yes, tell me please.
Here, if we take 13.09, it's gonna be over 100%.
Which one is 12?
If we take 13.09,
Okay. What's the answer?
it's gonna be 1.365.
Let's see what happens. 1 minus close parenthesis shift abs. Where's abs here? Abs. So we have here 12 minus 13.09, right? Correct? Go out, divide by 2.98, right? 2.98. Yes. We will get 0.634. This is what I've got. 12 minus 13.09 divide by 2.98. This is what I've got. So yeah. .634. 63.4. How about for the third one?
For the third one, it's gonna be 0.701.
0.071, which is
0.7, not zero. There is no zero. 0.701.
01. So this is 70.1%, right?
Yeah.
How about the last one?
0.365.
0.365 or
36.5%.
similarity. Very good. Ready for the next one, Riham? Riham, are you ready for the second one?
Wait, mister, wait. Wait some
No
minute.
problem. No problem, dear. Take your time. I'm just asking if you're doing it. No problem, dear.
Doctor,
Yes. Tell me, please.
I have a question.
Yes, what is it?
Yeah, so they're gonna give us two tables. The first one, we can take the numbers to match with the second one, like here, attribute and value.
Yeah.
So they're gonna give you the value here,
Yes.
and we can take the value so to match it with the here with the days.
Yeah. Yeah. So this day 1 to 4, right? So this is the day 5. This is the problem. Which decision we're going to make for day 5? You're correct. So from here,
And
continue.
and the range we calculate for each one.
Yeah, we calculate for each one. Highest minus the lowest. This one. 29.26, 29.50 minus the lowest, 27.01. Like
Okay.
this. Yeah, like that.
Thank you.
No problem. This is only difficult for the first time, but the more you practice doing it, the more you could solve it. Beer, are you still connected there? Beer, still connected?
Connection is not, the Wi-Fi is not very well with me.
Okay, no problem. Reham, ready? Not still? How about Reem? Are you ready, dear? Is Reem still connected?
Yes, Master.
Have you done it, dear? Not still?
Sure.
Okay, just tell me when you're ready, okay? Najla, are you ready, dear? Is Najla with us? Or she left?
Yes, Master.
Finished?
Yes.
Good, very good. So Gambang is finished already. Shall we go with the Gambang?
Yes.
Okay. Let me just put a note here. So we have ls of Gambang, close parenthesis, d5 and d1. Just hang on there, okay? I just have to do this 1 minus absolute value divide by 4 Gambang 3.78 minus, this is Gambang 20, right? Minus Okay, dear, tell me for day 1, 1 minus 20 minus 23, right?
1.
What's the answer, dear? Equals
0.206.
0.206 or 20.6%, similar. Good. How about day 2, day 5, and day 2?
0.738.
Wait, dear, 20.99, which is equal to 0. 0.2
2.
0.01 1
0.6.
6.
0. Yes.
Same as D1.
No, this one.
0.1 like this, or 20.1%. This is Gambang, day 5, day 3. This is 20 minus day 3 is 21.09.
7.
That's the answer.
738.
0.738. Oh, this is bigger. Or 73.8%. Good. How about D4?
No, Mr. 2. D2 is
D
3. D2 is 738.
7.3. This one.
Yes.
7.3.
D2.
2, as in 2, like this. Please check.
No.
I can't hear you clearly there. Let me just see. 1 minus shift absolute value of 20 minus 20.99, close parenthesis out, divided by 3.78. You will get
7.
I don't understand you. Internet connection problem. 20 minus 20.99.
0.738.
Ah, 0.738. Okay. This is for 2, nah?
Yes.
So which is 73.8%. How about this, the T3? Same?
No.
It's 63, I think.
0.71.
Okay, let me see. 1 minus close parenthesis shift abs 20 minus 21.09 close parenthesis out, close parenthesis, divide by divide by 3.78, 0.711, huh? Good. 711. 712, because it's 6 in there. So this is 71.2%. How about the last one there?
0.789.
0.789, like this.
Okay.
Thank you so much. 78.9%. Good. So this is 19.22. Good. I just have to verify so that we could finalize. 1 minus close parenthesis shift abs 20 minus 19.22 divided by 3.78 out close parenthesis equals what's different? Here what's different? 0.793. 1 minus close parenthesis shift absolute value 20 minus 19.22 out divided by 3.78
0.793.
yeah 0.793. So it should be 79.3%. Okay, so this is it. Thank you, Najla, for Gambang. Let's now proceed with soy. You ready, Riham?
Yes.
Okay, I'll just prepare this one. Okay, tell me please. Equals
0.1.
0.1
And D2.
This is finished. 0.1
Yes.
or 10%. D2, please tell me. Equals
0.04.
0.04, like this.
Yeah.
How about this?
0.9.
Like this.
Yeah.
0.9, like this, nah? So, or 90%. This one is 0.04 or 0.4? This, the D2.
0.04.
So this is 0.04%. How about this?
0.52.
0.52 or 52%. Let's verify, okay? Let's verify your answers. So this will be 20 soy, this is 20 minus 30.4. Okay, clear. Let us verify your answers. So 1 minus close parenthesis shift absolute value of 20 minus 30 out divided by 9.41 close parenthesis equals SD. Do we have the same output? Negative 0.0626. Anybody here from the group? Tell me please. We have the same output? I forgot to put something here. This is 0.40.4. Okay, let me just get the answers. Do we have the same answer? Anybody? 1 minus 20 minus 30.4 divided by 9.41. Do we have the same output,
Doctor,
please?
I am get the same answer, but I am choose only 0.1.
So the answer should be negative 0.105, right? So you have to write this negative 0 point, you have to take 3 decimal points, 105, or equivalent to negative
Okay.
10.5%. Right? How about the second one? Let's check the second one. So this is 1 minus close parenthesis shift absolute value of 20 minus 29.01 out divided by 9.41 close parenthesis equals 40.941. So this should be 0.042, right? 0.42. So this is actually 4.2%, right? Next, how about soy? Let's check about soy. Clear this one out. Let's see the output. This is 1 minus shift absolute value. Oh, sorry. 1 minus, clear. 1 minus close parenthesis shift absolute value of 20 minus 20.99 out divided by 9.41 close parenthesis. We will get 0.895. 0.895. 895, or equivalent to 89.5%. Then how about soy? The last one, D4. 1 minus close parenthesis shift absolute value of 20 minus 27.89, okay, divide by 9.41 close parenthesis equals 161, right? It's 16153. This is correct. 1 minus 27.89 minus 941. Correct. 5.2. So this is answer is so this is 0.161. 161. This is 16.1 for pecan. Okay, so we will wait for Rim to finish hers.
Yes, Master.
Okay, thank you so much. Let me just write something for you. This is LS of pecan. D5 versus D1 equals 1 minus absolute value of, let me just write the values first here. This is pecan is 22 minus 15.99 divided by 10.9. Okay, I'll just copy this formula so that will be fast later. Okay, good. Let me copy this, Control C, V. Okay, good. So tell me please there, what's the answer for the first one?
0.448.
Which is equivalent to 44.8%, right? Good. How about this one? Let me just change the value first. 17.9. 17.09. How much there?
0.549.
549, right? Or 54.9%. This is for day 2, right? For day 3, what's this one? 17.21.99 equals how much?
0.999.
This one, right? Or 99.9%. Then lastly, we have D4, which is
0.013.
0.093, correct? So this is equivalent to 9.3%. 22 minus
73. Not more.
73.
Yeah.
This one, like this?
Yeah. No. 0.073.
Ah, 0.73. So this is 7.3%. Okay, 22 minus 11.09. Good. Let us just verify your answers there. If it's correct. 1 minus shift absolute value of 22 minus 15.99 out divide by 10.9 close parenthesis equals, yes, very good, 0.44. Actually this is 449 because you have to round off 6 to make it 9 here. But anyways, for the practice, no problem for that. But for the exam, you have to be specific with the rounding off of the numbers. So this is 1 minus shift absolute value of 22 minus 17.09 out divided by 10.9 close parenthesis equals 0.5495. So this is also 50 because you have to round it off to the third. Okay, be careful with the rounding off of the numbers. So this is 55.0%. Then next, clear, this is 1 minus close parenthesis shift absolute value of 22 minus 21.99 out divided by 10.9 close parenthesis equals shift 0.999. So this is actually 1%. 1 or simply 100%. Okay. Next, let's go with Pecan D5. So let's see this one. 1 minus shift absolute value of 22 minus 11.09. Then Be, 10 minutes na lang naman, patapos na. 12 o'clock, tapos na ako. Kasi marinig yan. 10 minutes na lang naman, no? Konting tiis na lang. Matatapos na rin to. Sige na.
Naririnig ka?
Oo, naririnig. Kumakalabog. Ako pa, naririnig ko sa headset ko eh. Mamaya na.
Naririnig ka yung gumagawa ng bahay?
At least yung gumagawa ng bahay yan, pagkain yan. Patayin mo muna, mamaya na lang.
Nakapatay na.
10 minutes, 9 minutes na lang, patapos na ako dito. Konting tiis na lang.
Nakapatay na nga eh.
Bagutin mo para din nag-iingay. Bagutin mo dun sa baba. 10 minutes na lang na patapos na ako. Where am I? So this is let me just check if the output is correct here. Divided by 10.9 equals, oh, it's like this. I've got the wrong answer. 1 minus 22 minus 11.09 over 10.9. Did you get the same output like this with me? 10.09. Do we have the same outputs like this, all of you? Let me see what happens here. Because I have got very small value. Parenthesis was forgotten. So this is negative 9. Who got this value like this with me? Let me just verify it again. 1 minus close parenthesis shift absolute value of 22 minus 11.09, then out here divides by 10.9 close parenthesis equals so same, this is negative 9.17 times 10 to the negative 4. So how do you count this? This is, so I have to write it first so that you will see. This is 0. This is minus 4, right? So this is negative 0.1234 174,917.9. So this is almost 0. So we just have to write here negative 0. So this is almost 0. So this is, or simply around 0%. Ibrahim, could you please verify if we had the correct calculation for LS Pecan D5, D4, please? So Ibrahim is no longer here. How about Abir? Can you please verify if this is correct? This one, because I'm not sure about this. 1 minus shift absolute value of 22 minus 11.09 divided by 10.9 close parenthesis equals 9.17 to the minus 4. So we have 4 zeros, 1, 2, 3, 4, 9, right? So it's almost negative 0. So please verify it if we have the right answer. So this is for Pecan. So 21 minus 11, this is 10.21 minus 11, 29.99 minus 11.09, we will get 10.9. Yeah, correct. Is this correct? I'm not sure this is correct. 21.99 minus 11.09, you will get 10.9. Yes, it's correct, 10.9. So this is correct, the last calculation. Everybody is correct. Is this correct, everybody? Riham, could you please try to calculate if this value here is the same with you? So we are done we are done for this. We're done for the similarity calculation. So we will continue the next part, which is GS. Next meeting, God willing, we're going to discuss the calculation for global similarity. Global similarity calculation. Okay? Next meeting you will do it, and we will try to make a calculation of this. Okay?